All right, we're going to go through some more of how to use exponential logs and how to differentiate them. We're going to, in this particular example, are some applications of how to find equations of tangent lines and normal lines. And just for a little review, tangent lines are where we need a slope, which is going to equal dy dx, which is our derivative of the function. And this one is actually a perpendicular slope to a tangent. So when we find a normal line, it's a perpendicular slope to a tangent. I'm going to be using slope-intercept form, point-slope form for all of my equations, just to make them fast and efficient when I write them out. All right, so first off, to find this, we need to find the equation of tangent line, so I need to find the derivative, all right, dy dx for this particular example. Now, to do this, I am going to first factor out an e dx, because I noticed that I have an e dx in this equation. So I'm going to factor this out. And when I do that, make it a little bit easier, because now I'm going to use the product rule. And so I'm going to have the derivative of e dx, which is e dx, times x squared minus 2x plus 2. All right, and add that to the derivative of the next function, which is going to be 2x minus 2 times e dx again. From there, I'm going to plug in, because I'm going to find y prime of 1. And so when I do that, and I'm also going to factor out e dx too. So I have e to the first, and from here, I'm going to have 1 squared minus 2 plus 2 plus 2 minus 2, and we have that. This will cancel out, this will cancel out, and I'm left with, well, it appears to be e. Wow, that's pretty neat. So from here, I can find my tangent, because now I have my slope, which is that. And I'm going to use that, and I'm going to go y equals e to the x minus 1 plus e. All right, because I'm going to use my point right here, and I'm going to use point slope form, which I stated up there. And my normal is simply going to be perpendicular to that. Perpendicular means we're going to have opposite reciprocal slopes. So we're going to have the opposite of 1 over e times the quantity x minus 1 plus e. And that's my normal. All right, let's try another example of this. Okay, find tangent and normals, and now I have a log function. So once again, I need a point, or a slope and a point, because that's whenever I need this, I need a slope and a point, which is my dy dx, and my point, which I'm given right here. All right, so now we're going to take f prime of x. To make this a little bit nicer, I'm going to use some properties. I'm going to put the 1/2 out here, because we know, according to logs, you can write this as natural log of 1 plus sine, I'm going to write this as sine x squared to the 1/2 power. Put the 1/2 in front using the properties of logs, and I have 1 plus sine of x, that quantity squared. Sometimes students like to see that a little bit better, just so you can know you have to use the chain rule. Okay, so from here, I'm going to take the derivative of this, and I have 1/2 times the quantity 1 over 1 plus sine squared x. I'm just going to write that because it's a little bit nicer. Times the derivative of the inside, which is going to give me 2 sine x times cosine x. And we have cosine of x right there. From here, I'm going to find f prime of pi over 4 now, because I'm going to plug in my point to find my slope. Remember, I'm finding my slope first. The derivative is the slope of the tangent line. So I have 1/2 times 1 over 1 plus sine squared, and we have the square root of 2 over 2, the quantity squared, and then 2, and then we're going to have plug that in there, and we get square root of 2 over 2 times the square root of 2 over 2. All right, so from here, do some simplifications, and that will cancel out right here. I'm going to have that turns into 2, so it's going to turn to 1/2 right there. And now what I have remaining should equal 1 over 1 plus, right there is going to be 1/2 as well, times 1/2. And when we have this right here, we can distribute this 1/2 through. And when we do that, we're going to have 1 over, I'm going to distribute that to there, which is 1, plus the 2, and we have 1/3. Okay, so there is my slope. I can write my equation, my tangent. And the equation of the tangent is going to be y equals 1/3 times x minus pi over 4. And if we go over here, it's going to be natural log plus the natural log of the square root of 3/2. Make sure I got that. Yes. Okay. So that's my tangent. My normal is going to be the opposite or perpendicular to that. So the normal line is using the same point, but now I have -3 as my slope, x minus pi over 4 plus the natural log of the square root of 3/2. All right. So there is an example of using the equation, or both exponentials and logs, to find equation of tangent lines. Hopefully that helps out, and hopefully you can finish your homework or know a little bit more about how to find these different things.